let's talk about how to find attributes of a parabola in two different forms. So you can see your equation of a parabola written in standard form, which is ax squared plus bx plus c, or in vertex form, y equals a times x minus h squared plus k. We're able to find the same attributes in either form, but the formulas are going to be a little bit different because obviously the values that we have are different. So either way, you're going to have a graph of a parabola either pointing up or pointing down. So for standard form, your vertex, which is a ordered pair x comma y, can be found by doing negative b over 2a for your x value, and then f of negative b over 2a for your y value. And that looks a little bit tricky, but f of that value just means you're plugging in the x value to your equation to find the y value. So if we wanted to practice that, we want to make sure that we're first in standard form, meaning that we have our x squared, our x, and our constant all on the same side, and we do. So for this particular problem, I've got an a value of 1, a b value of 8, and a c value of 7. So to find the vertex, for my x value of the vertex, I have negative b, so negative 8, over 2 times a, 2 times 1. So my x value of the vertex is going to be negative 4. Okay, so I have negative 4. For the y value, we're going to take that negative 4 and plug it back into our original equation. So we're going to have negative 4 squared plus 8 times negative 4 plus 7. And if we plug that into Desmos, we would get a negative 9. So our vertex for this particular parabola is at negative 4, negative 9. Okay, when we're determining if it has a minimum or a maximum, remember minimum is where it has an absolute low value, just like absolute value, and it opens up. Maximum is where it has a absolute high value, the maximum, and it opens downward. So just like when we did absolute value, we're looking at the a value. So if it has a positive a value, it's going to open upward. And if it has a negative a value, it's going to open downward. So this one had a positive a value, so it's going to have a minimum. It's going to open up. Okay, our axis of symmetry is going to be a vertical line. It's going to cut our parabola in half, and it's going to go through the x value of our vertex. So you have x equals, since it's a vertical line, the x value of our vertex is represented by negative b over 2a. But we've already done that calculation because we had to do it to find the vertex. So this is the x value of your vertex. So over here, we could say our axis of symmetry is at x equals negative 4. And then your y value is just 0, c. Your y value is where it touches the y axis, your y-intercept. So x is always going to be 0. So here, our c value is 7. So our y-intercept is just 0, 7. So that one, we don't have to do any calculations. We just look for that c value. Okay, so let's do example number 2. I have an a value of negative 3, a b value of 18, and a c value of negative 39. Those are already all in standard form. So for my vertex, for my x value, we're going to look back at our formula over here. And I see that we want to do negative b over 2a. So for my vertex, I have x equals negative 18 over 2 times negative 3, which is going to be negative 18 over negative 6, or a positive 3. So my x value of the vertex is positive 3. Okay, to get the y value, we plug it in. So the y value of the vertex is negative 3 times 3 squared plus 18 times 3 minus 39. So if we come over here to Desmos, I've already got that typed in, and we get -12 for our y value. So we can say the y value of our vertex, whoops, is -12. So 3, -12. For our minimum and maximum, we're looking at our a value. So for this parabola, I have a -a value, so we're going to have a maximum. That a value, when it's negative, just like absolute value, is going to reflect it vertically. So we have a parabola that's facing up, the a value becomes negative, and it's now facing downward with a maximum. Okay, our axis of symmetry is at x equals -b/2a, which is the x value of our vertex. We want to make sure to write that as an equation. So x equals 3. And then our y-intercept is at our c value. So our y-intercept is going to be at 0, -39. Okay. We're going to actually be able to ignore this because we're not converting from standard to vertex form. And on your physical copy of your notes, that's not there. So that was just left over from something else. Okay, so vertex form, we have this random h and k, which we've never dealt with before, but those are going to be the same thing as what we had for our c and d values in our absolute value. So you could technically write this as y equals a times x minus c squared plus d. And your c and your d, actually your a2, are going to do exactly the same thing transformation-wise as they did with your absolute value function. Okay, you still have x minus c, so it's going to do the opposite of what you think, et cetera, et cetera. So your vertex is going to be located at the point h, k, or we could say c, d. Remember, h and k, c and d represent the same thing. So it's going to be the opposite for your c value or your h value as what it appears. So in this first example, I have an a value of 4, an h value of 2, because remember, it's the opposite of what it appears, and then a k value of 7. So my vertex is going to be at the point 2, 7. Okay, our maximum and minimum are going to be the same thing as if we were in standard form. So a minimum is going to occur when I have a positive a, maximum is going to occur when I have a negative a. So +4 gives me a minimum. Axis of symmetry is going to be located at x equals h, or you could say x equals c, exactly the same as absolute value. Okay, for this one, we have a c value or an h value of 2, so we have an axis of symmetry at x equals 2. For your y-intercept, in standard form, we were able to easily get that from our equation, but for your y-intercept here, it's going to be at the point 0, f of 0, meaning we plug in a 0 for x to get our y value. So over here, we're at 0, I need to plug in a 0 to see what my y value is. So we have y equals 4 times 0 minus 2 squared plus 7, which is going to give me 16 plus 7, or 23. So this one has a y-intercept of 0, 23. Okay, our transformations, like I said, are exactly like absolute value. So if you need to refer back to your transformations notes from absolute value to get more detailed notes, you can absolutely do that. So a value can be a vertical reflection, or you can say reflection across the x-axis. It's also going to be your vertical stretch and compress. So like I said, if you need to refer back to your previous notes to see when it stretches, when it compresses, absolutely do that. Okay, your C value is going to shift left and or right. And then your D value is going to be shift up or down. So they occur exactly the same instances as they would in absolute value. So for this first example, I have an A value of 4. So since that's greater than 1, it's going to be a vertical stretch. I have an H value of 2. So I have a positive H value, which is going to shift to the right 2. Okay, remember H and C are the same thing, K and D are the same thing. Okay, or we could say it says X minus 2 in our equation, so that's also going to represent the shift right. So it's going to shift right 2, and then it's going to shift up 7, because I have a positive 7 for my K value. Looking at example 2, I've got an A value of negative 2, H value of negative 4, K value of 6. So my vertex will be located at negative 4, 6. I'm going to have a maximum because I have a negative A value. My axis of symmetry is at x equals negative 4. My y-intercept is at 0, whatever I get when I plug in a 0. So let's go ahead and do that. Negative 2 times 0 plus 4 squared plus 6. So that's going to give me a negative 32 plus 6, or a negative 26. So 0, negative 26 is my y-intercept. And then for transformations, I've got 4. I have a vertical reflection because my A value is negative. I have a vertical stretch because my value is 2. So the negative does the reflecting. The 2 is going to be a vertical stretch. My C value, or my H value, is negative 4. So it's going to shift left 4. And then my K value, or my D value, is 6. So it's going to shift up 6. So you'll recognize that some of our attributes are easier to find in one form or the other, but we've got formulas for all attributes in both forms. Now, for our transformations, you could get your transformations from standard form once you know your attributes. So your A value does the same thing. So an A value of 1 does not reflect, stretch, or compress. Over here, an A value of negative 3, even though it's in a different format, we can still use our A value the same. So that tells me that it's going to be a vertical reflection and a vertical stretch. Now, your B and C values don't do what your C and D values do in the other one, meaning you can't look at this C value and do the same thing. To get your shift, to get your horizontal shift and your vertical shift, you would look at the vertex. So we would say from a vertex of 0, 0, if I go to 3, negative 12, I've gone to the right 3 and down 12. So you can get your transformations from standard form. You would just first have to find your vertex to see where that vertex shifted from the origin.